Okay, this is from the book Medical Reformation by me, Pete Rogers, and we're actually on page 556. It says 569 because this is sort of like my demo copy where there's a little bit that's been added to it. It's 566 of the actual book. The section heading is What Causes Mitochondrial Dysfunction? Okay, I've already gone through most of the illustrated chapters. This chapter is a little bit dry. We're just going to go through a lot of sort of like biochemistry of cancer. So this is really for more of a highly motivated audience. This is not going to be a walk in the park. But it might still be interesting to you. So first of all, we've talked a lot about the mitochondrial theory of cancer. So the question arises, well, what causes mitochondrial dysfunction? What damages mitochondria? And of course, hypoxia will do it. Otto Warburg, who won the Nobel Prize in 1931, noted that when you put human tissue culture cells into a hypoxic environment, they will sometimes transform and become cancer cells. And it's thought that happens due to mitochondrial injury, that they retain some ability to revert to anaerobic metabolism, just like the original earliest multicellular organisms on Earth back when oxygen was not that widely available. So they needed to be able to shift back and forth between oxidative metabolism with the mitochondria and anaerobic metabolism with the cytoplasm, glycolysis. Okay, and the cancer cells doing that, where they take up 100 times more glucose than other cells, and that shows up on PET scans as increased uptake of glucose, fluorodeoxyglucose, FDG. That's called the Warburg effect, Otto Warburg. Named after that German biochemist. Okay, the next thing is saturated fat. Fat in general, but saturated fat in particular, will inhibit the intermitochondrial membrane electron carriers. It sends too many electrons too rapidly to the intermitochondrial membrane, and it gets into the cell more rapidly than glucose does because it can just go right across the plasma membrane of the cell, for example, in the skeletal muscle by the flip-flop maneuver, so to speak. So it overwhelms the intermitochondrial membrane, pumps too many electrons into the intermembranous space, and then you build up the pressure gradient too high and it shuts down and starts to reverse. You start dropping electrons into the matrix, producing superoxides, which if there's too many of them, it overwhelms the neutralization system like a superoxide dismutase, and then you can start getting these side reactions to damage DNA and damage the intermitochondrial membrane as well. Okay, so that's an important point. Excessive amounts of fat, especially saturated fat, can damage the intermitochondrial membrane. The next is intracellular hyperglycemia. Some cells are not glucose type 4 transporter dependent. So what that means is skeletal muscle cells are, but there's other cells that are not, like endothelial cells, the arterial lining cells, like the cells on the peripheral nerves, like some kidney cells, and like some cells in the eye, some retina cells. And that's why these are very common complications of diabetes. So what I'm talking about is a skeletal muscle cell after you eat, postprandial that's called, after eating, will only take up glucose in proportion to what the activity of insulin binding the insulin receptor, and then that insulin receptor, once activated, signals for glucose type 4 transporters to come up to the plasma membrane. So the cell, in a sense, is protective from excessive uptake of glucose. There's other cells that will just let the glucose come in just in whatever proportion it's present within the blood. And that includes the cells I just referred to. Endothelial cells, arterial lining cells, so you get a microvasculopathy in diabetes. Nerve cells, like to your lower extremities, that's why you get a peripheral vasculopathy with diabetes. And number 3, retinal cells, that's why you get diabetic retinopathy. Number 4, kidney cells, that's why you get diabetic nephropathy. All of them have constitutive uptake of glucose such that they take it up in proportion to its concentration in the blood. So you can see the higher the blood glucose on a prolonged basis, the worse it is. A transient spike upward in blood glucose is normal after eating, but if it's chronically, markedly elevated, that will damage cells. Okay. And the reason this all matters is when you damage mitochondria, you then increase the chance that that cell will become dysfunction, certainly, like it might go into apoptosis in the brain, or just simply might turn into cancer. Excessive amount of PUFAs, they can undergo lipid peroxidation. You can get into the whole iron ferroptosis business. A lot of mitochondrial toxins, like in pesticides, and I've given separate lectures on mitochondrial inhibitors, and I went through all the literature, and I quickly found over 50 of them, and a lot of them are common. And one of the points I made in my own mitochondrial, not the Warburg effect, but my own mitochondrial inhibitor synergistic effect in cancer, what I was saying was you don't just get a mitochondrial injury from hypoxia, you get it from all these toxic chemicals, and they're likely contributing to increased risk of cancer. Because like I said, they're super common. Tylenol, aminoglycoside antibiotics, fluoroquinolone antibiotics, beta-lactam antibiotics. You know, they're toxic to mitochondria, some of these things. In a bug, they're also going to be toxic in humans. What else? Tons of things. Statins, selective serotonin reuptake inhibitors, mitochondria inhibitors, metformin, Haldol, propofol, and there's a whole bunch of other ones. Glyphosate, BPA, bisphenol A, the estrogenic plastic. Okay, in addition to hypoxia, sat fat, intracellular hyperglycemia, free iron, mitochondrial inhibitors, what can generate a lot of reactive oxygen species, ROS? Okay, the enzyme for NADPH oxidase is often abbreviated NOx, NOx, and it can be overactivated by AGEs, advanced glycation end products, related to diabetes when you've got insulin resistance, okay? When you've got hyperglycemia, you're going to start glycating things, and that can, activate then the RAGE receptors. They call them RAGE receptors, receptors for advanced glycation end products. Okay, what are some other things that stimulate cell growth? So when you got cancer, you don't want to be stimulating cell growth. So you don't want things that activate mTOR, for example. So we talked about meat having more leucine. Leucine is a branched chain amino acid that tends to be a rate limiting step for activation of mTOR. That's the reason why you want to avoid meat. That's one of the many reasons why you want to avoid meat, especially if you've got cancer. You want to avoid estrogenic chemicals. Meat will often have the animal given estrogenic chemicals because the fat storage hormone to fatten it up for slaughter. Okay, things that increase insulin like growth factor, that's also anabolic. High-fat diets can increase ILGF, and that can lead to increased activation of mTOR as well. You don't want that. mTOR, of course, we talked about it before. It's a nutrient sensing pathway that when the nutrients are available, like a building contractor having everything it needs to build, it'll give the build signal. Meat has a lot more methionine. That's also going to be a rate limiting step for activation of mTOR. What causes DNA mutations? There's a lot of things that can do that, but tobacco smoke, deficiencies of folate and B12 can become relevant. Anything that increases oxidative stress, like free iron, excessive iron overload. People are big time iron overloaded pretty routinely. Okay, I'm not going to get into all this genetic stuff. Things that decrease the risk of cancer. So what are some more of the things you can do to protect yourself from cancer? Eat a low-fat, low-sodium vegan diet, 100% vegan. Nothing from an animal. Animal protein in general increases your cancer risk, especially like the milk proteins, casein and whatnot. Fish is bad too. Fish is an animal. There's not that much difference from one type of animal food to another. They all tend to be high in protein, high in fat. And even the so-called lean meats are typically at least 25% fat, which is still, I would consider high fat. I want my total fat intake below 10%. And there's a joke, meat's unsafe at any speed. And this goes back to the tables of data that T. Colin Campbell had. He's the best protein researcher in the world, and he would show that if you look at the slope of the curve, it goes right through the zero axis, meaning that there is no safe amount of meat. For reducing your risk of disease, it's best to not have any. Okay, nowadays you can take a methylcobalamin supplement for vitamin B12. So because Nathan Pritikin back in the day around 1980 thought maybe you should eat a little bit of meat to get vitamin B12, but it's pretty easy to get that now, and I prefer methylcobalamin. I don't like cyano because you know what cyano is. I don't want that potentially adding up in my body. Plant food's got all the good stuff. They got the antioxidants like vitamin C, etc. They've got the nitric oxide precursors like the nitrates. They're alkaline, so they prevent metabolic acidosis, which can increase the rate of cancer growth. They got other good things. They got the potassium and the magnesium, the vasodilators. It's all that you want. Okay, we talked enough about how bad animal protein is. I got entire separate videos on that if anybody cares. Animal fat is also bad. Animal fat especially means saturated fat. It impairs blood flow, leading to decreased oxygen delivery. It's associated with increased cholesterol. There's plenty of problems with it. And then you can even get into more subtle things, byproducts of it. They're all bad. You'll get increased bile salts heading down into your colon to dissolve the fats. So that's another problem that it causes. It increases your risk of leaky gut. Your best thing to eat is starch and also fruits and vegetables. Okay, this is just a chart giving you a sense of what's in some of these foods, the percentage of calories from the different things. So soybeans, first of all, are much higher in fat, in the range of 37 to 40% of the calories from fat. So that's like the fattest bean. In comparison, garbanzos are about 13% fat, but, lentils are the lowest fat bean. They're like 3% fat. I usually eat lentils. Peas and black beans are about 4% of calories from fat. White rice and potatoes only 1% of calories from fat. That's kind of what you want. You want your diet to be about as low in fat and low in protein as possible. You know, Kempner's diet was in the ballpark of about 94% calories from carbohydrate and then about 4% from fat. And you know, maybe 3 and 3, right around the ballpark of 3 to 4% of both protein and fat. I think it was more like 4% of protein and about 2% of fat, 2 to 3%. Okay, so because by lowering the amount of protein, you gave the kidneys a vacation, because the kidney's main job is to excrete the nitrogen from protein. There's no protein, there's no amino acids, nitrogen in fat and carbohydrate. In addition, the fat caused insulin resistance, so he was protecting the patients from that, because that was ended up being, and also the fat causes hypertension. He's trying to protect a lot of his early patients from hypertension and from kidney failure. So that's why he wanted a high carbohydrate, low fat, low protein diet. Okay, nuts. I'm not a fan of nuts just because they got too much fat. They're in the ballpark typically at 80 to 90% fat. Here's Brazil nuts, 86% fat. And then look at all the meat. They're all bad. Look at salmon, 50% fat, 50% protein. In general, there's no carbohydrate in meat, you know, the exception being milk, you know, the lactose. But in general, they're mostly just fat and protein, which is a good reason to avoid it. So that gives you a sense. And there's plenty of omega-3s in low-fat plant foods. You don't need to go searching for them. And I do think fruits are better than is widely acknowledged. Exercise dramatically decreases your risk of breast cancer. And, you know, again, we talked about exercise. It activates the AMPK pathway, adenosine monophosphate instead of ATP, adenosine triphosphate. When you're tired after exercising, that's actually good for your body, because then it goes into what's called the restoration phase with the AMPK pathway, where it tries to rebuild your ATP levels, to restore your energy levels. And lots of, you know, famous long-term cancer survivors, like, of course, famously Ruth Heidrich, PhD, patient of Dr. McDougall, and there's other ones, Janet Marie Wakelin and other ones. Okay, anyways, they ran a lot. And when you exercise, you activate the lymphatics in your body, and it's the lymphatics moving around that pumps your, the muscles moving pumps your lymphatics, because your arteries and veins are connected to your heart. Your lymphatics are not. They're parallel to your arteries and veins. And so what moves them is your muscle contraction, and you can increase lymph flow 30 fold by exercising, and you'll get those white blood cells to travel around faster and surveil your body and remove the metastatic cells. They do all kinds of good things come from it. You get better self-esteem, better physical appearance, better energy levels in the long run. You sleep better. It causes nitric oxide to open up arteries. It's all good. Okay, get your sleep at night, lower your stress level, have at least one good social relationship. So you got to try to maintain your friendships, which means, you know, you got to do nice stuff for people, and don't give people a hard time for no reason, because sometimes, yeah, the person did something stupid or obnoxious, but most of the time it's of trivial significance, and it's best to just let it go. Helping other people doesn't just help them, it helps your own self-esteem. You get release of reward neurotransmitters in your brain. Being religious also lowers stress levels. Having some type of loving relationship in your life, you know, however that may be, also makes you healthier. Having a purpose in your life, it energizes you, you know, and that's a good thing. As long as you have to have at least one thing you're enthusiastic to wake up for in the morning, that you hope for, that you strive for. That makes you a lot more resilient. And lots of people have noticed that, you know, Fyodor Dostoevsky, Viktor Frankl, Nietzsche, and a whole bunch of other ones. Things that increase cancer risk here. Now, you want to avoid these carcinogenic chemicals, and, you know, they're usually pretty obvious. Don't smoke cigarettes. Don't smoke MJ. Don't drink alcohol, okay? Avoid fumes, okay? Avoid car exhaust, especially diesel exhaust, okay? Genetic vulnerability. Some people are a little more vulnerable, but usually the genetic vulnerabilities are not that bad, like these, you know, the BRCA genes, breast cancer genes. You know, if they eat a low-fat vegan diet, avoid these estrogenic chemicals, they're in pretty good shape. EDCs, endocrine disrupting chemicals. We talked about that in other chapters. Being sedentary is bad for your health, increases cancer risk. You don't activate your lymphatics like we just talked about. And all those other good things that come from it, your AMPK pathway. Aluminum is much more widespread than people know. We talked about it in the context of it gets in your armpits, you know. Upper outer quadrant breast cancer used to be about 30% of breast cancer. Now it's about 60% of breast cancer. Shared lymphatics from the armpit to the breast. So don't be sticking deodorant in there. It's aluminum. Aluminum is a metalloestrogen. The preservative is typically something like parabenzoic acid. They're also estrogens. and they're getting, shared. Estrogens stimulate proliferation of breast ductal cells, increase your risk of breast ductal cancer. What do people do? They shave first. They increase transdermal absorption. Your skin is primarily lipid, and it keeps out water. Okay, but on the other hand, in chemistry, like dissolves like. So estrogens are lipid. You start slathering lipids on your skin, it's going to be transdermally absorbed. Okay, not good. When you walk in a room, you say, hey, how you doing? You don't sniff each other's armpits. We don't need deodorant. It's for low IQ conformist behavior. Alcohol is real bad. It's a carcinogenic chemical. You don't need to drink any alcohol. I haven't drank any alcohol since college. I actually drank one time, like when I met some of my wife's relatives. She told me I had to drink or they would think I was weird or an alcoholic. But in general, it's a bad idea to be drinking. There's nothing good about it. Alcohol is stupid. When somebody says, oh, don't you want to get stoned? Don't you want to get drunk? It's like, that means you poison your brain. Why would you want to poison your brain? That's stupid. Okay, some breast cancer risk factors. Most patients are over 40. Mammography is a whole overrated thing. Peter Gochke's talked a lot about that. If you're symptomatic, yeah, it's a good idea. But if you're a young woman, you got all that dense breast tissue, you're going to be more likely to have false positive. Okay, anything that increases estrogen unopposed is going to increase your risk of breast cancer. So there's a whole bunch of things. Being obese, because there's aromatase enzyme in the fat, early menarche, early onset with all these chemicals causing precocious puberty, like in the milk and whatnot. Late menopause, nulliparty, late age of childbearing, no breastfeeding, long-term OCPs, oral contraceptive pills, hormone replacement therapy. Okay, and then all these personal care products, I try to avoid them. And drinking water too. Make sure you at least filter with a carbon water filter. Other general risk factors for cancer, like we talked about, high animal protein diet, high animal fat diet, alcohol, obesity, tobacco, sedentary, diabetes. Watch out for implants. They can be a lot more toxic than people realize, especially if they're wrapped in polyurethane foam. Watch out for some of these hair dyes, I would try not to use that stuff if I could avoid it. Electric blankets. You don't need electric blankets. Let's see. Watch out for cleaning chemicals. They're toxic to bugs because they're toxic to us as well. You don't want to live near some factory, gas station, or refinery if you can avoid it. You don't want to be sleep deprived. Okay, and then I got some books that are pretty good on cancer. Some of the classic books, like the T. Colin Campbell China Study book. Christy Funk, I like her, even though I think she was a little bit lazy. She didn't study soy as much as she should have. It's good to read about the Ornish study on prostate cancer. These are some other doctors that wrote something interesting. Dr. John Kelly wrote about, don't stop feeding your cancer. Ruth Heidrich wrote some good books, and they've all got videos. This lady here survived metastatic breast cancer for a couple decades. What is the connection between excess estrogen and breast cancer? Well, it just causes proliferation of breast ductal cells, so you want to avoid that. Oh, and if you eat meat and you don't eat enough fiber, you get bad gut bacteria, and they'll deconjugate your conjugated estrogens excreted from your body into your bile, and you'll reabsorb the estrogen. So you definitely want dietary fiber. It helps you to excrete estrogens from your body and excess cholesterol. Okay, and you got to keep your good habits. Sometimes, patients who've had a remission for a while on the vegan diet, they get cocky and they go back to eating meat, and then they often die rapidly after that. I've read several case reports of that happening. Because I think cancer cells are sensitized. They've got a whole bunch of receptors on their plasma membrane ready to take up glucose, take up iron, take up whatever they can get their hands back on. So it's don't look back, just like, Orpheus should have not looked back and Persephone was dragged down into hell. Eurydice is the other name. How come older women get more breast cancer even though they're postmenopausal with decreasing endogenous estrogen levels? Well, it might have been brewing for a long time. They got weaker immune systems. They've accumulated a lot of estrogenic chemicals. Also, I noticed that women like to rub chemicals on themselves. I've seen that. In my bathroom, I only got one transparent bar of soap, the fewest chemicals possible, whereas my wife had 55 cosmetic products in her bathroom. And I just seen women in general. I remember my mom used to have all these cosmetic products. You can bet they've all got estrogenic preservatives in them. I don't like that stuff. Okay. All right. Advanced discussion of cancer, monoclonal origins. All right, this gets into a little bit about how cancer grows. I'm not going to go into all this stuff. It gets a little dry. But the gist of it is, think of the cancer cells being in a competition with the surrounding normal cells. And then the question becomes up, well, what favors cancer? What favors normal cells? Activation of mTOR favors cancer. Hypoxia favors cancer. An acidotic milieu, meaning you're eating dietary sodium chloride's replacing bicarbonate in the blood. You're eating a lot of animal protein, so you got more sulfur-containing amino acids that are partially metabolized sulfuric acid, leading to low-grade metabolic acidosis. Animal foods in general, high-protein foods in general, with all the amino acids. Okay, and you got acids in your fats too, fatty acids. You don't have carbohydrates are not acids. Okay. They're not significant acids. All right, so next is presumed carcinogens. All these are just some more toxic chemicals, and you get into a debate over what somatic mutation theory, sort of like what conventional medicine goes by, toxic chemicals damaging the DNA, causing cancer, versus metabolic theory, saying that injury to mitochondria causes the cell to shift over to a different form of metabolism, which I think is a much more useful and accurate theory of cancer, much more relevant most of the time. So yeah, my point is, if you want to survive, don't give your cancer any tumor promoters. So no meat, nothing from an animal, no oils, no alcohol, no tobacco, no estrogenic chemicals as much as you can avoid them. And so I sort of say my rationale, like if I had cancer, I'd want to starve it, So you sort of say, okay, Mr. Cancer, you made a little spot for yourself inside of me, but I'm going to make you wish you were somewhere else. I'm not going to give you any tumor promoters. I'm going to alkalinize your milieu to make it harder for you to compete with the adjacent normal cells. I'm going to optimize oxygen delivery to your area, again, to favor the normal cells. I'm going to exercise a lot to keep my white blood cells surveilling you tightly and removing any cells that attempt to metastasize. I'm going to improve my immune function with good sleep, good exercise, managing my stress, avoiding caffeine, okay? I'm going to do all this psychosocial stuff that makes me happy and positive and fulfills my sense of purpose and destiny, so that I'm resilient and strong and my immune system remains at its best to remove any metastasizing cancer cells. Okay? I'll help other people. I'll be religious. All that stuff, I think, improves survivorship of cancer patients. Okay? And then I like these quotes here. The belief that life is worth living. Believe that life is worth living, and your belief will help create that fact. I think there's truth in that. If you live like your life is meaning, your life will have more meaning. Okay, Dostoevsky, does faith spring from miracles, or do miracles spring from faith? Like my mom, she had a 2-year prognosis, but she lived about 11 years, and she did all kinds of things that made her happy and that helped other people. Minister of care at the church, director of an orphanage, tour guide at the art museum, tour guide for an architecture facility, tennis player, charming, funny, super nice. All of that, I think, helped her. I just feel bad that I didn't know all this nutrition, cancer biochemistry stuff. When I was young, I just thought you send the patient to the specialist. What else could anybody do? I didn't realize that I could read their field and know it better than them in terms of the nutrition and lifestyle stuff. Okay, critics of somatic mutation theory say that mitochondrial dysfunction and metabolic problem is the initiating event, and the Genome Atlas project really, did not support somatic mutation theory. Metabolic theory of cancer, we talked about it plenty, injury to the mitochondria. The book Tripping Over the Truth by Travis Christofferson is pretty good. He's good at explaining basic biochemistry. I think he's a little bit trapped in being a little bit of an idiot and hanging around with Seyfried. Seyfried also did great research, but they're kind of stuck on keto for cancer, which I think is idiotic. I'm like, dude, read the biochemistry of Krebs cycle, and you won't even say such a stupid thing anymore. Okay, these are all some of the famous mitochondrial metabolic cancer theory researchers. We talked about Otto Warburg. Let's see, is there anything interesting? I've talked about how Krebs cycle can go in reverse with cancer, which is quite interesting, reverting again to its primitive and like early life phase, where it could do that in the early anaerobic organisms. It could run retrograde. Let's see. He also said none of the so-called accepted causes of cancer in the absence of a high animal protein diet mattered that much. It was not genetics, not chemical carcinogens, not viruses. Okay, this is a big statement. So T. Colin Campbell, the world's expert on the effect of protein on cancer, he basically says the most important thing is the tumor promoters, and the most important thing was having animal protein available. So he says if you can minimize animal protein, in his experience, and which is especially experiments in mice, but it was dramatic. He could turn cancer on and off, okay, by reducing the amount of animal protein the animal was eating, which is quite remarkable. Okay, one thing I wonder though is, T. Colin Campbell, he was feeding them typically, from what I could gather from reading about some of these experiments, a monoprotein source, like just casein or just soy or just some other protein. Whereas in real life, we eat a variety of proteins, and the point being is that you're low in one essential amino acid if you only feed a monosource and it's low in something, and a lot of plant proteins are. But if you're feeding a variety of proteins, are you maybe not just now by adding them all up to a synergistic effect, now having those enough available that you can make the cancer grow? So I think you got to be careful about that, and it's good to be low in protein in general. Okay, a little bit about cancer metabolism. I talked about this earlier with my illustrated chapters, but I wanted to have this chapter in here because I go into a little more biochemical detail on certain things that I didn't have illustrations for. And it's just more about explaining why hypoxia is so damaging to cells. Okay, John McDougall, based on the work of Peter Quo, high-fat meal decreases PO2, pressure oxygen in the blood, by 20%. And Warburg said if you could get normal cells in a tissue culture, you deprive them of oxygen, you could turn them into cancer. Okay. Some people say that the glycolysis excess in cancer cells is mostly because they want to go through a synthetic pathway. And they just need the carbon skeletons. And that's the main theory sort of promoted in some of the current pathology books that I have. But I don't think that quite fully explains it. Okay, let's see, what else? Oh, we talked about, the metabolic theory of cancer, the paleo-keto diet, I think, being kind of stupid. All right. Actually, I think we'll talk about metastases next time. We'll end it there for today. I hope that was interesting for you.